This is part 1 of lesson 5.4. We're going to be doing quadratic modeling using the vertex form. So what we're going to do is determine how to write the equation of a graph of a quadratic relation in its vertex form. We've seen, for example, how to write the equation in its quadratic form. So if we had a graph with zeros, you could plug in your zeros in the factored form. I should have said factored form instead. Plug in the zeros into the factored form, find the value of a with at least 1 point, and then you have your factored form. But now we're going to take a look at, with certain information, how can we do that for the vertex form. So before we go into actually deriving the vertex form or determining the vertex form, we're going to take a look to see if we know the basic information that exists in the vertex form. So here we have a variety of vertex forms provided to us. Let's start with the first one here. What is the vertex? It's always that HK here. So the vertex in our situation here is 5, 3. Remember the change of sign of the H there. Let's go and try our axis of symmetry. So our general rule for axis of symmetry, where you can split the parabola down the middle into left and right sides, is that it's going to be equal to the x value of your vertex. So x is equal to 5 is where the axis of symmetry will be. Direction of the opening, well, since there's a negative over here, this means that the direction of the opening is down. It's down. So our next step is to figure out the number of zeros. How many zeros are there? Basically, how many times does the parabola hit the x-axis? So let's go see if we can kind of figure that out based on some information that we have here. Our vertex is 5, 3. So I'm just going to do a quick rough estimate. 5, 3 is over here somewhere. So it's right side up 5, 3. The parabola opens downwards, so it's not going up, but it's going down. If it was going up, that way, it wouldn't be hitting the x-axis because the vertex is above the x-axis, and going up means you're never going to go back down to the x-axis. But in this case, our direction is down. So our vertex is 5, 3, and our parabola opens from the bottom. So that means that it must cross the x-axis, and it's going to do that on both sides. So in a situation like this, we're going to have 2 zeros. 2 zeros. Let's take a look at this situation here. Let's choose a different color. Let's do blue. So again, let's go find our vertex. We have -1 because it's positive 1 here, so let's change that sign, and then -5. Great. Our axis of symmetry again is going to be the x value of the vertex, so x is equal to -1. And then our direction of the opening, our A over here, is positive. So that means this opens upwards. So we have to find the number of zeros. So we'll do a quick little sketch to estimate how many zeros there are. So our vertex is -1, -5. -1, -5. So let's just say it's here and then here. That's -1, -5. Quick sketch. If it opened from the bottom, our parabola would go down this way. It would go below -1, -5, and so it would never go back up to the x-axis. But this opens from the top, so what that means is a parabola is something like this. There and there, which means it has to hit the x-axis twice. So that means that there are 2 zeros for this situation as well. Let's take a look at our next example. Let's choose a different color here. Let's do this purple color. So our vertex, look at the H, plus 7 in there, so change the sign, -7. Our K is -2. Remember that the axis of symmetry, where you can cut it in half left and right sides, is going to be the x value of your vertex, which is x equal to -7. The A value over here has a negative. So what that means is this opens down. And we need to figure out how many zeros there are. So let's draw a quick little sketch here. Right here. Our vertex is -7, 2. So let's go over here. This is -7, -2. -7, -2, rather. This opens from the bottom. So -7, -2. It's going to open from the bottom, this way. Notice because it keeps going down, it's already below the x-axis. It's not going to cross the x-axis anymore. So there are no zeros on the x-axis. There are no zeros on the x-axis. So there are no real zeros on the x-axis, so we can write 0 there. Next we have x squared plus 6. I know this doesn't look like a vertex form. You know this is a binomial. It's not factorable because of the plus there. But remember, this is, in a way, a vertex form. It's written, it could be written like this. Y is equal to x plus 0 squared plus 6. So we don't have to write it this way because there's a 0 there, so it's just x squared. But the idea is that our vertex would be 0, 6. It's basically our x squared graph moved up 6 units. That's all it is. And so our axis of symmetry is still along the y-axis, so where x is equal to 0. There's a positive a, so that means that it opens upwards. I didn't use a different color here. I should have. I'm going to switch for the last question here, green. How many zeros are there? Well, let's take a look. Let's draw a little graph. This will be in green. Let's put our vertex, 0, 6. So let's just say 0, 6 is over here. This opens from the top. Our vertex is already above the x-axis, and it's opening from the top, so it's going up. It's not going back down. So there's no zeros on the x-axis here. It's not going to hit the... If it opened from the bottom, yeah, we draw it going down like this, and it would hit the x-axis. But here it's going up. It's already above the x-axis, so 0 zeros on the x-axis. And so that if you can get that information from the vertex form, you have a good general understanding of what the vertex form means, and you can do a quick little sketch to give a reasonable view of what the parabola looks like. But now we're going to take a look at more specifically how to derive this equation from some information given to us. So if you know the coordinates of the vertex, hk, and one other point on a parabola, you can find the equation using y is equal to a, x minus h squared plus k. And we're going to write down the steps to allow us to do that. So in our first step, when you're asked to find the equation in the vertex form, you want to plug in the vertex for h and k. So if you have the vertex, put in the numbers in the h and k spots if you're given that. Our next step is going to be to sub in the other point that you know for x and y. So you'll be given another point, and you'll put that point into the x and the y accordingly. And when you're doing that, what you're going to do is, the reason you're doing that is because you want to solve for a. So you're going to have your y, your x, your h, your k, and you're just solving for a in the end. And then, once you find your a value, you're going to sub a into the final equation. So those are the main steps we're going to follow. We'll start the first example together, and then we'll finish the other examples in the following video. So here we have a parabola, passes through the point negative 5, 6, and has a vertex negative 3, negative 10. Find its equation in the vertex form. So we're going to follow the steps that we said above. Remember that the vertex form is y is equal to a x minus h squared plus k. We have our vertex, which is negative 3, negative 10. So we're going to go and do the first step where we plug that information in there. So y is equal to a x. The h is the first term here. That's the h. We have to change the sign of our h when we put it in because it's negative h. So it looks like this, negative, negative 3. Now it might make more sense why we change that sign. And the k is the second term. So plus minus 10. And I'm just going to clean that up a bit so it looks a bit nicer here. Y is equal to a x minus 3 plus 3 squared. Don't forget that, otherwise you no longer have a quadratic equation. And then plus minus, so it becomes minus 10. So now all we need is our a value. And we can actually find that because we have another point in this parabola. We can go sub this point into our preliminary equation here, and then find out what the a value is. So I'm going to do that in a different color. So this is step 1. Now we're doing step 2. So our y is 6 is equal to a, and then our x is negative 5 plus 3 squared minus 10. Then we get 6 is equal to a. Negative 5 plus 3 is negative 2 squared minus 10. So 6 is equal to, so negative 2 squared is 4. 4a minus 10. Now we can solve by basically doing plus 10 on both sides. That gets rid of the 10 on the right side, so we get 16 is equal to 4a. Now that's not a yet because we only have 4a, so we have to divide by 4 on both sides. Crosses that out, and therefore we get a is equal to 4. So now we found our a value, and we can go plug it back in to the first equation that we had over here. So what we did is we subbed and solved for a. So those two steps were done over here, subbed and solved for a. And now what we're going to do is we're going to go rewrite our final equation with the a value plugged in there. So the final equation is going to be y is equal to a, which is 4, brackets x plus 3 squared minus 10. And so from this information, you can do a quick sketch of your graph to figure out how many zeros there are if you were asked that. So for example, my vertex we know is negative 3, negative 10. So I have negative 3, negative 10 all the way down here, let's just say. We know it opens from the top because the a is positive. So what that means is it must be going up this way. So that means that it must be hitting the x-axis twice. And again, from the information given, the vertex and the single point, we're able to go and find the vertex form using these main steps over here. So what we're going to do now is we're going to do another example. I want you to pause the video, try it yourself, and then see if you got the same answer. So a parabola passes through 1, 4 and has vertex negative 1, negative 4. Find its equation in vertex form and standard form. So in this case, we're asked for the standard form as well. So we'll probably have time to find the vertex form in this video, hopefully, and then we'll continue the standard form in the next video. So we're going to start off with the vertex form first. So 1, we know that y is equal to a x minus h plus k. Let's go sub that h, k into our equation. So y is equal to a x plus 1, because minus minus 1 is plus, and then minus 4. Now we can go plug our values into the equation to find our a. So we have 4 is equal to a, oh, and I should put a squared here. See, I forgot my squared. If you forget that again, that's wrong, so make sure you put squared. A, x is 1 plus 1 squared minus 4. And then we get 4 is equal to 1 plus 1 is 2 squared, so that's 4a minus 4. Solve by adding 4 to both sides. So we get 8 is equal to 4a. We divide by 4 on both sides. What you do to one side, you must do to the other. And so we get a is equal to 2. And then we can go and sub that in, so we get y is equal to 2x plus 1 squared minus 4. And so this is our vertex form. We're then going to convert it into the standard form by simply expanding, and we'll do that in the next video.